Alrighty, hey guys, welcome to my video number 3 presentation by Mariella Manipol for Materials for Industry, Professor Pastor at Tidewater Community College. Today I'll be doing my ceramics presentation on kaolinite. So kaolinite, it is a clay mineral, specifically a silosilicate sheet silicate. The chemical composition is 2 aluminum, 2 silicate, 5 oxygen, and 4 hydroxyl groups. For the crystal structure, it is a layered 1-to-1 structure with 1 tetrahedral silica sheet and 1 octahedral alumina sheet. It is smooth, soft, slippery, and has an earthy and soapy feel to it. It is chalky white and fine grained. One fun fact about it is that you can consume it. So here's an example of the crystal structure, the 1-to-1 layered structure of the tetrahedral sheet and the octahedral sheet. Where is kaolinite found? So kaolinite is common in kaolin clays, which is also called China clay. It is found all over the world in countries such as the USA, the UK, China, and Brazil. Some properties of kaolinite. It has a particle size of 0.1 to 10 micrometers, meaning that it is very fine. It has a white to off-white color, a melting point of 1700 degrees Celsius, so it does not melt easily, a low plasticity as compared to ball clay, a low shrinkage for drying/firing, and a high refractoriness, which is important for whitewares. So kaolinite has uses in multiple industries, such as ceramics, paper, and paint/coatings. In ceramics, it is used for porcelain and fine china, filler and coating for paper, which improves brightness and visibility, and in paint/coatings, it is used as pigment and extender, which improves opacity, brightness, and durability. Now let's dive into the manufacturing process of kaolinite. The mining process. The goal: to extract kaolinite-rich clay from the earth. Here we have an example of a kaolinite mine in front of us. For prospecting and exploration, kaolinite is located in high purity deposits. Open pit mining, which I'm sure is this example right here. They use shovels, backhoes, and draglines. For blending and transport, clays from different areas are mixed to ensure consistency. Refining/beneficiation. The purpose is to remove impurities like sand, mica, and iron oxides. Some common steps are slurrying. As we can see in the picture here, slurrying is clay mixed with water to form a slurry. Screening and cycloning. It removes coarse particles. Magnetic separation. It removes iron or titanium impurities. Flotation/bleaching. It improves the color and purity. Finally, filter pressing and drying, which removes water to form a cake-like material. Forming and fabrication. Once refined, kaolinite can be shaped into products. Plastic forming. It is mixed with water and other clays to make it moldable. Pressing, used for tiles, insulators, and porcelain pieces. Slip casting, which I'm sure is the example right here. It is used in fine ceramics. Liquid clay is poured into molds. As we can see, liquid clay was poured into molds for a toilet. Conditioning and firing. Conditioning, drying and controlling moisture content. For firing, it is heated in kilns of 1000 to 1400 degrees Celsius. Kaolinite transforms from a state of mullite and glassy to a state of more strength and translucency, as we can see from the left picture to the right picture. Finishing and quality control. Finishing, glazing, polishing, cutting, or coating. For the quality test, they check the whiteness, the particle size, moisture and impurity content, and then packaging. The product is shipped as a dry powder or wet slurry to manufacturers to use as they please. Now we have some environmental considerations to take into account. So mining of this mineral kaolinite can disturb land and water, so reclamation plans are used. Companies will then have to refill the mined areas and replant vegetation so it can go back to its natural state. And then modern plants that are grown recycle water and minimize chemical waste. Thank you so much for coming to my presentation. Here are my citations. And I'll see you guys later. Thank you.